So this video is on the sine, cos and tan graphs, and we're going to learn how to sketch them and also how to solve equations with them. So we'll first start with sine, not sin, it's sine, okay. Okay, so here I have my axes and I'm going to draw the graph of y equals sine x. So normally we're used to seeing y equals like 3x plus 1, stuff like that with numbers and maybe an x, but these are called trig functions. So now we're going to try and draw these. So the axes for these look like this. So sine and cos oscillate between 1 and -1, which is really important. And then these work in degrees. So here, they kind of have cycles and they keep repeating. And they go between 0, which is here, and 360 degrees. So that means this point halfway is 180 degrees. And then slotting in here, we have 270 degrees and 90 degrees. Now we have the same on the other side, so here we have etc. Really important things are these scales here and the fact they oscillate, so they go up and down between 1 and -1. So the way I remember a sine is you think sine wave. Let's draw a wave. So the way this works, so this is what a sine wave looks like between 0 and 360. So this is one oscillation of the sine wave. So it goes like this. So that is a sine wave because it looks like a wave. So you say sine wave. And as you can see, it goes between 1 and -1. And it does one full up and down before it gets to 360. And it goes to 180. Now, it's important to note that this does just keep going forever that way, and then also it'll come this way. So as you can see, this wave just continues forever that way and forever that way, but this is this is one oscillation, the main bit you normally have to understand. So now we're going to have a look at the sketch of the cos. So cos is very similar to sine. So if we draw the cos graph, it also oscillates between 1 and -1, and these scales are the same. And now if we look at one oscillation of cos, we call this, we have sine wave, and this one is called a cos bucket. So it's called a bucket because it starts at 1, so sine started at 0, but cos starts at 1, and it goes like this. Cos bucket. So, just like sine, again, this will come. Okay, so one important thing is that cos is symmetrical about the y-axis. And again, just like sine, it keeps going forever and ever in that way. So if in an exam they wanted you to sketch a cos graph, they would tell you to sketch it and they would also give you a region. So it might say the normal region would be where x ranges from 0 to 360. But that's one very important thing to look out for, is the region. Now I'm going to show you something quite clever. So here in green is a wave that I made earlier, and as you can see at the moment, it looks exactly like the cos bucket. It fits our graph really nicely. Now I'm going to shift it by 90 degrees, so I'm going to go from 90 to 180, 270 to 360, shift it all to the right, 90 degrees, and we'll see what we have. So that's what I get if I shift it 90 degrees to the right. Now that looks exactly like the sine wave. Can you see it starts at 0 and it does this whole wave before it gets to 360. So cos and sine graphs are exactly the same, they're just shifted along the x-axis by 90 degrees. Okay, so now we're going to look at the tan graph, and the tan graph is a bit different to the other two, and the reason being is that because it has these points that are undefined. So first of all, if we just put our scale on the x-axis, now I'm going to draw on the points at which is it undefined, and that means that the graph doesn't actually have a value. Okay, so those dashed lines there are actually called asymptotes, and it's the point that the graph doesn't have a value. So I'm going to draw what tan looks like. So from here, this would be the first section. This would be the 0 to 360 oscillation. So it goes there, up again, and there. So it's a bit funky, and at these points it doesn't have a value because this orange line here will never touch this red line. It'll just get closer and closer and closer until it's like infinitely close, and that value, it will actually go up to infinity. So as you can see, it doesn't have 1 and minus 1 on our y-axis, and down here it also goes to negative infinity. So for 90 degrees, so tan x, so tan of, this is the x, 90 doesn't have a value because it's undefined, never touches this line. Tan of 270, tan x, tan 270, exactly the same. And then this also just oscillates like that. So yeah, tan is a bit different, and we mainly work with sine and cos, but it's very important to know it has these undefined points at plus or minus 90, plus or minus 270, and then plus or minus other points if we kept drawing out this x-axis. So now we're going to look at answering some questions using these graphs and solving some equations, and also doing some little sketches. Okay, so this is our first question, and it says sketch y equals sine x for the values, so for the x values from 0 to 720. So first of all, we're going to draw some axes. And we know that for the sine graph oscillates between 1 and minus 1, so really important to put those on the y-axis. Now we need to go from 0, so from x is 0 here, we need to draw a graph, to 720, and we know we have these units here. So we know that one wave went from 0, so it was a sine wave, so it went to 360. And if we do another 360, so if we did another wave, we're going to end up with 720. Now we can fill in the parts in the middle, the numbers on the x-axis in the middle, just to make it easier. And then we don't need to write any more because we haven't been asked to sketch between that region. So very important to look at these values. It looks complicated and like they're just being faffy, but that's really, really key. So we know it's a sine wave between 0 and 360 because that's where we kind of learn to sketch them. So first of all, let's do what we know, sine wave. So it starts at 0 and does a from 1 to minus 1, a wave. Okay, but now we're not going from 0 to 360, we're going 0 to 720, so we do the whole thing over again. So starting here, let's do the wave again. And now we have, as you can see, it is a sketch, it's not the best. We have our sine graph from 0 to 720. So that just shows how the same thing repeats itself. So this question said, given that sine 30 equals a half, and then you've got to find sine 150 and sine 330, and it gave you a sketch, so I'm going to draw a quick sketch. So it gave you the sketch of y equals sine x from 0 to 360, and it wants you to solve those in that region. So it's important that they've specified that, basically. Okay, so it's told us that sine 30 is a half. So what would sine 30 look like using our graph? Because obviously you can solve these using a calculator, because you might have noticed that these bottoms are on there and you could just type it in. But they're going to need to show, so you're working out on a graph to show you understand the graphs. So let's find sine of 30. So we know if we're looking at our graph, we have y equals sine x. So the x here is 30 degrees. So 30 degrees is going to be, there's 90, so, and it equals a half, so the y is going to be a half. So half, that's 1, so half is about here. So if we go along half, it hits there. Okay, so we're going to look for 150 along our x-axis. So 180 is there, so it's going to be about, somewhere about here. And 150, here, the gap to 180 is 30 degrees. So this is about 150. So if we go up on our graph, what is the y value? What is our graph saying at 150? And as we can see, it's also a half. So we know it's a half. And that is because also this has symmetry here. So between 0 and 180 it has symmetry. So we can see here that that is 30 away from 0. And this 150 is 30 away here. So they have the same value, which you can see much easier using this sketch. So that is y equals a half. What if we look now at sine 330? So we need to find 330, and we don't know exactly where that is, but we want x, so sine x, sine 330. So 330 along the x-axis is somewhere here. And we know we've got 360 there, which we know where that is, and that again is 30 degrees away. So that's how we're going to use this piece of information. So if I go down here, I want to know what the y value is, so I'm going to go along and I would read it off. But I can see using symmetry and things like that because that was 30 away and that is 30 away but at a different point, it's going to be here, instead of positive a half, it looks like minus a half. So that's how we've used that information there. So you look that is 30 degrees away. So I hope that makes sense. You're trying to see from the graph the differences. You can always check it on your calculator, but you do need to show the workings on the graph. If we were asked to solve the equation that sine x equals 0, algebraically we see that we want to get rid of sine, so we do the inverse operation, and the inverse operation for sine is sine to the minus 1, or shift sine on your calculator. So if you put shift sine of 0 onto your calculator, you get the answer 0. So let's just check that. So we're saying sine x equals 0. So when is y 0? Y is 0 here, and yes, x is 0. However, and this is why it's very important to have a graph, y is also 0 at this point and at this point. So if you just did it looking at your calculator, you'd be missing these two values. And there would be more if we were looking at a bigger x scale, but within our region of 0 to 360, that sine x equals 0 at 3 points. And if you're doing that on your calculator, you probably would only think of having this first point. So that's why it's handy to draw the graph. Okay, so let's look at this question now. And it says sketch y equals cos x for, and then x ranging between 0 to 360. So they're kind of the boundaries we like. So let's draw our axes. We know it oscillates between 1 and minus 1 on the y-axis, and we're going from 0 to 360 on the x-axis. So I'm going to fill in the in-between bits. Okay, so we know we're sketching a cos graph, and that means cos buckets. We're going to draw a bucket, which means we start here because we want buckets. This one starts at 1, not 0, and we're going to go through 90. And then we have our cos bucket sketch from 0 to 360. Now, using our graph, it's asking us to solve that cos x equals -1. So we've sketched y equals cos x. So in this part, what have we done? We've said that cos x equals -1. So we're saying that y is equal to -1. So within this region we're solving this for. So if we go to y equals -1, what is the x value? And it should be, depending on my sketch, this value here. So x is 180 degrees. The next question says, so we're solving 5 cos x equals 5. So we've got this 5 in the way, and that's not really in our sketch. We want to get rid of it. So we're going to take the 5 over the other side, and it's multiplied on this side, so we're going to do the inverse. So we're going to do divide, so 5 divided by 5, which equals 1. So we have cos x equal to 1. And we've sketched y equals cos of x, so cos x equals 1. So we're saying setting y equal to 1. So we need to look at our y when y is 1, which is here. What is x? So that is 0. And also y is also 1 here, and what is x? 360 degrees. So in this region, they are our two answers. Okay, so I've just written out the points that I think are really important to remember, and that is that the sine is a sine wave, so it starts at 0 and it goes like this, and that's one oscillation, but then it continues forever and ever either way. We have cos bucket, so it's a bucket, so it starts on the y line at 1 and it does a bucket in one oscillation, and again continues forever and ever. Remember, these two are the same, just shifted 90 degrees. The y values, so along the y-axis, they oscillate between 1 and -1, that's really important. And the x values for one oscillation is 0 to 360, but again, it can continue forever and ever. And then for tan comes up less, but it has those undefined points for which it doesn't have values, or also known as asymptotes.